All right, next I want to talk about how these high and low pressure systems plus Coriolis force affect the pattern of global climate. So just to recap, winds are created by the unequal heating of the Earth's system. And their direction is influenced by that. Their apparent direction is because of the Earth's rotation due to Coriolis force. So let's start with the first one. This is a theoretical Earth that is not spinning. If the Earth was not rotating, then what we would have is we would have differences in temperature between the equator and the poles. At the equator, you would have warm air that's rising like a hot air balloon. And as it's rising, it's going to be kind of pushed outward up in the upper atmosphere to the poles, where it would become high pressure. At the cold places, it's going to be moving back down. And that would set up a big loop, a global sized loop of air rising at the poles. I'm sorry, air rising at the equator, I should say, and then moving downward at the poles. So the North Pole and South Pole would have high pressure, and the equator would have low pressure. Now, assuming the Earth is not rotating. So here's another way of looking at it. We've broken up these into different latitudes. We have the equator at 0 degrees, 30 degrees north, 60 degrees north, 90 degrees north at the poles, and also for the southern hemisphere. If the Earth was not, this is more of a three-dimensional view, if the Earth was not rotating, we would have one big cell of circulating air from the equator to the poles. However, the Earth is rotating, and that creates what's called Coriolis force. And because of the rotation of the Earth, the patterns become more complicated. Instead of one big air pressure cell, it creates smaller air pressure cells and more complicated wind patterns. So we're going to look at these different pressure zones and wind patterns individually. Okay. So now we're on a spinning system that's a bit more complicated. Whereas before we had this big cell that moved all the way to the pole and back. Now we have a smaller cell that moves about to 30 degrees north and back. So here's a side view of it. The ones between the equator and around 30 degrees north and south, these are called Hadley cells. So instead of going all the way to the poles now, we're just going to about 30 degrees north and to about 30 degrees south. Air rises at the equator, then comes back down here. This would be about where North Africa is, very dry conditions, as well as in the southern part of Africa as well, where you have the other deserts as well. And those are called Hadley cells. And then there's other cells as well. It's called Ferrel cells and polar cells. The point being, there's these series of cells. I encourage you to watch the climate video I'm going to post that kind of shows you that more 3D, this system of cells. And the effect of this is to create these different zones of high and low pressure. We have right at the equator where the air is rising, we have what's called the intertropical convergence zone of low pressure. Then the air is coming back down at what's called the subtropical high pressure zone, around 30 degrees north and 30 degrees south. Then the air is rising again at a zone called the polar front, north and south. Then the air is descending again at what's called the polar high. So you're going to need to know these air pressure zones and where they are. So let's go over them one more time. We have the ITCZ for short. It's called the Intertropical Convergence Zone. This is at the equator where you have a low pressure system and the air is rising. Low pressure, air going up. Right? Now that air that's going up is coming back down around 30 degrees north and 30 degrees south. This is the subtropical high zone. This is a high pressure zone. By the way, if it's low pressure, it's wet. See these clouds near the equator? Where it has high pressure, it's dry. So high equals dry. And the pattern changes again around 60 degrees north and south where we have the polar front. The polar front is a low pressure system with wet conditions. like around northern Canada and the interior of Russia, where we have vast wet forests. And then the air is descending again at the poles, at the polar high. And the North and South Pole may not be so obvious, but they actually have dry conditions. Even though they're so cold, they can be covered with snow, but they don't have a lot of precipitation compared to the polar front or the equator. So the polar high is a high pressure zone. That's the polar high. So here's another view of it in 3D. You have air rising at the equator. This goes up in a cell and then back down at the subtropical high. The same thing happens again, where you have air rising at the polar front, descending at the polar high. I'm going to include a video that kind of shows this in 3D and kind of explains this in a little better detail graphically. So make sure to watch the associated videos that I'm going to post with this. It will help you kind of visualize and understand these patterns. The high pressure zones tend to be over oceans where like they have different names, like the Azores High for the Azores Islands or the Hawaiian High. And from these cells in the ocean, air goes from high pressure to low pressure. So air blows from these high pressure belts outward, and it's going to blow in a pattern due to Coriolis force. In the northern hemisphere, a clockwise pattern. So from the subtropical high, you have air blowing kind of from west to east. These are called the westerlies. Or in the opposite direction near the tropics. These are called the trade winds, blowing from east to west. They're called westerlies because they come from the west to the east. These come from the east to the west. So know these winds, especially these top two. You have the trade winds. These are the primary winds in the tropics. Tropics being that zone of the earth that's near the equator. Here the winds are moving from east to west. Whereas in the mid-latitudes, like where we are in California, you have the westerly winds. These move from west to east. There's one other wind called the polar easterlies. These don't influence, we don't see much effect from these because these are limited to the polar regions, but these really just blow around and around in a circle due to Coriolis force. However, when we talk about climates and different climates of the world, westerlies and trade winds are going to have a profound impact on the climate of different places. And we'll come back and look at an example of that. So here, just one example with the trade winds. In places like Hawaii, where you have a mountainous island, where the trade winds hit the island, you have a wet side because the air is moved up, is being forced upward, and then you actually have a drier side where the air is moving downward. So typically these winds, trade winds are very stable, but when they strike an island or other object and move upward, they become very wet very quickly. Here in Hilo, Hawaii, they get 150 inches a year of rain, which is extremely heavy. Fresno typically gets less than 10. So just to recap, those 4 pressure belts and 3 sets of winds make up the 7 components of general circulation. We have the intertropical convergence zone, a zone of low pressure at the equator. We have the subtropical highs, a zone of high pressure around 30 degrees north and 30 degrees south. We have the polar front, a zone of low pressure at 60 degrees north and 60 degrees south, and the polar highs at the poles. In between these, blowing from high pressure to low pressure, out of the subtropical high, we have winds going in this direction. They're converging at the intertropical convergence zone. That's why it's called that. These are the trade winds. They're moving in this general direction. And then blowing on the opposite side, we have the westerly winds. These are blowing from west to east. So make sure you read and pay particular attention to these 7 components of general circulation. Now for the exam, you will need to be able to identify each of those on a figure that looks something like this, right? But it'll have some labeling like A, B, C, and so on. And this is what the figure on the exam will look like. The ones with the arrow are prevailing winds, like the trade winds or the westerlies, and the thicker lines are going to be the pressure belts. So just to recap, the ITCZ is at the equator at 0 degrees. The subtropical highs are going to be at 30 degrees north and 30 degrees south. The polar front is going to be at 60 degrees north, 60 degrees south, and we'll just skip over the ones above that. We also have two major winds here. They move in a curved direction, but I try to simplify this to make it easy to understand. The ones that move from, let's start up here, from west to east are the westerly winds, right? The ones that bring air from the Pacific Ocean into California, those are the westerlies. In the tropical zones, air is moving in the opposite direction. It's moving from east to west. These are going to be the trade winds. So make sure you can identify each of these 7 elements of circulation, or at least 5 of them shown here, on a figure that looks like this. Another thing I want you to be mindful of, especially with these pressure belts, is these are going to be important when we talk about different kinds of climates. So in the intertropical convergence zone, where you have very warm and wet conditions, this is going to be where the world's rainforests are, like here in the Amazon basin in South America. Some of the major deserts of the world are going to be underneath the subtropical high, like here in northern Mexico, or even like Death Valley where we live. Up here in the north, is like in Canada, is where we have cold and wet forests. Not so much in the south because there's not much land there, and then in the North and South Pole, you're going to have cold and dry conditions. So these pressure belts really set up along with the winds, set up kind of a global template for the kind of conditions you're going to have in different parts of the earth.